And I would be like, okay, here's like my evidence. Like I didn't have any idea what it meant, but it was like, this is what I have observed. And I had this PowerPoint, and it was crazy because people would be like, oh my gosh, like I've never seen that before, or no one's ever said that before.
Hey everybody, welcome to another Wavetronix Pulse podcast where we talk about everything traffic related. I'm Todd Hansen.
And I'm Melina Wright.
And today we have a very special guest. Her name is Janine Price. She is a trailblazer in manufacturing engineering and a process engineer at Wavetronix. Janine's journey has taken her from growing up as the only girl in a house full of brothers to being the sole woman at BYU's manufacturing engineering program in the 90s, to designing and building her own home in record time.
With career highlights at Motorola, Dell, and now Wavetronix, Janine specializes in optimizing processes and implementing cutting-edge technology. Outside of work, she's an adventurer. She swam with sharks, lived abroad for years, and never backs down from a challenge. Join us today as we dive into Janine's inspiring story and learn how she's innovating manufacturing and beyond.
Janine, welcome.
Thank you. It's good to be here.
We're excited to have you. I mean, you've got such a diverse background that we could probably talk for hours, maybe just about swimming with sharks, right?
That's a fun one.
And can you contrast that with dealing with manufacturing engineering instead of swimming with sharks?
It's always scarier when you talk about it than when you actually do it, is what I would say.
Okay.
You just got to dive in and believe that it's going to work out.
Yeah. So tell me about growing up with all brothers and how maybe that helped shape your life for the future.
So I was probably already a little bit of a tomboy to begin with, but I remember really distinctly one day that my brothers were playing with army men on the ground, and I had a stuffed animal, and I love stuffed animals. So I came up to them, I was like, hey guys, you want to play stuffed animals? And they turned to me and they said, we play army or we don't play. And I just remember like tossing my stuffed animal and being like, all right, give me an army man, but it made it so that I think I probably learned to be really competitive because that's the way it was in my house. And so I grew up playing soccer and ball, like baseball, whatever was going on. I was in on it. And, when my brother made a big tree swing and the boys were scared to try it out, they dared me to. And I went for it and I ended up like splat on the ground, but I was brave and that's what mattered. And so I would say it just like made me probably like a little more competitive and more brave than I might have been otherwise. I don't know.
And maybe pursuing a career field that women don't traditionally get into or didn't back then.
Right. So that's the funny thing is that like I actually showed more interest in a lot of these things that are a little more male centric career wise than my brothers. And so like when my dad would be fixing the car, I would be the one that didn't mind that he was swearing and just be like, hey dad, can I help you fix the car? And get into that stuff. And so I don't know that they necessarily influenced me to be, towards engineering, but my grandfather was an inventor and he started a couple of different businesses. So I feel like it's maybe in my blood somewhere.
So you did manufacturing engineering. But you said you were looking at two other majors as well. What made you, what about manufacturing engineering was so attractive to you?
So I've always kind of been like an efficiency-oriented person where I loved strategy games. I always loved to figure out like the best way to drive home, the quickest way to get something done. And so that was something that came really natural to me. The major that I had right before this was industrial design, which is similar, but it's a little bit more in the art space. And, they would say things like design a round refrigerator. And I'd be like, round is a bad shape for a refrigerator. And so I was having a little conflict with that. And then I had a semester where they had us take a crossover class with manufacturing engineering. And so in my manufacturing engineering class, they wanted us to make an orange juicer. In my industrial design class, they wanted us to make an arthritically friendly device. So I was like, well, I'm making an arthritically friendly orange juicer. And so I did, and I had to make both a kind of like a model that would show like what it looked like and then a working model. So like I get to work on this, and I'm kind of having fun with the working model a lot more than my visual model of how pretty it's going to be. And you could tell in my end product that I had I was like, well, it could kind of look like this, but you could probably round it out better if I had, my own injection molding supplies. And then I actually had like a really nice working orange juicer. And so I took all of this to my industrial design class, and my teacher's like, ooh, like he's like, this looks like crap. And I was like, well, thank you for the evaluation. Yeah. Like a little bit crushed. And then I went to my manufacturing engineering class, and we had a competition where like we were distributed boxes of oranges, and you had up to 3 or 4 people on a team. I was a single team, just me. And we got 3 minutes or so to, start squeezing oranges. And with my little just desktop squeezer, I produced more than twice as much as any other team.
Wow.
And yeah, so it was like I blew everyone away, and it was just me. Like there were other teams where it was like 4 people doing everything that they could to squish the oranges. And one of them had like a welded, crank. And mine was just a really simple design where it rolled the orange and sliced it and then squished it. So it kind of like opened it up and gave it a squeeze. And my teacher came by, and he was like, hey, why don't you come talk to me in my office? And so I came by a little bit later, and he was like, that was really cool. He's like, I'm wondering, why aren't you in manufacturing engineering? And I was like, I'm beginning to wonder the same thing myself, because my other teacher just told me that I did a craft job this semester. And I was halfway through my junior year at that point in time. So I went home, and I had like this really contemplative week where I was like, I am going to like take a lot longer to graduate if I do this. But I decided, I had some background because I was on scholarship, so I wasn't really paying to go to school. And I was like, you know what, I can do this. It's going to be fine. And I'd rather like leave school with something that really made me happy. And so I didn't tell the registrar's office or anything. I was just like, I just switched majors, and it ended up, adding to my graduation time, but no regrets here at the end. Just really happy with it.
Yeah, I was going to say it paid off. How much time did it add?
About 1.5 years. So I spent more. I had more graduate or like credit hours for my undergraduate than my husband did when he finished his PhD. But I joked around like, it's the well-rounded program. Ask me questions. I know answers.
And it wasn't because you were a professional student. You knew what you wanted to do. It just took a minute.
Eventually, yeah. I loved Legos when I was a kid. I thought about engineering. I didn't love calculus. And so that kind of was like making me shy away a little bit. But then after dabbling in other things, I was like, I got this. I can do the math.
Now, you came to Wavetronix on a temporary basis. Is that right?
So I was just at the tail end of my master's degree, kind of after I had my first career where I'd gone through and worked for Motorola, worked for Dell. I stopped and hung out with my kids when they were really little. When my daughter was born, I stopped working, and I was at home for just a little under a decade. And somewhere along the way, the kids were in school full time, and I was just like, man, I got to do something with my life. And my husband's a professor, so I was able to go back to school for free. So I decided to freshen up my degree and go get a master's. And it was a little intimidating at first. I wasn't sure if it was just like dried applesauce in my brain, but it turned out that I could still remember a lot of things, and I had a really fun time doing my master's degree. Near the end, I needed to do a project at a business, and 2 doors down, one of my neighbors is Van Newby, who's one of the people who's been here at Wavetronix for a really long time. And so I'd heard him bragging about Wavetronix for decades, about how awesome it was. And so I approached him, and I was like, hey, can I come to a project? And he, of course, said yes. And I came here and did a student project. And then that turned into contracting. And I contracted a little bit longer than most people because I had like sworn to myself that I was not going to take a job until I'd finished my master's degree. Because especially with my husband being in a PhD, like he would just talk about all of these people who are like, I'm going to be done. And then they take a job and they never finish their degree. And so everyone worked with me here. And so I was contracting and just kind of doing what I could until I finally walked out with my research and piece of paper and became a full-time employee. And it actually really worked out well because then I didn't have any stress about the job being right for me, and everyone here knew they also liked me. So it's like, it was a very low stress hire.
From the time you started to now, how has the manufacturing process changed or evolved at Wavetronix?
So it's been really fun to review like some of my first PowerPoints when I'm like, how about we do this? How about we do this? How about we do this? And then to look out on the floor and see it has been put into practice. And a lot of the things, because they're just principles that will work, I can't say, this one thing, that when we put in the the solder paste inspection that could automate the beginning of the solder on the board, or when we went to, and reorganized how we switch between boards. There's probably about 12 different big changes that we implemented. And while you can't say this one was 5% increase, this one was a 12% increase, we could see, looking at the boards, that like for one of our main boards for Matrix, that we can produce 98% faster than we were. And so like almost doubling the production speed without hiring new people, just mostly strategy and a little bit, and like a piece of equipment or two.
I think Janine's probably spent millions of dollars here at Wavetronix.
Oh, yeah.
Yes.
How, I guess, with talking about the manufacturing process here at Wavetronix, how do you approach optimizing the processing of the SMT line or stuff in that category? Like, what do you do when you approach that?
It's a great question. So a lot of it is actually like intuition, that I feel like I love strategy games. And so I feel like between like just intuition and training that I've received, that I can kind of look out there and see things that might exist, and then I can design an experiment. Like I did this a couple of years ago. We were building one of our other Matrix products, and I was taking forever. And I sat there and I was like, I think that our machines, even though they're both the same brand, are actually, they've got personality. One of them is a newer machine than the other, and we knew that machine could build faster than the other machine. But I started to have this like little niggle that was like, you know what, that one, not only can it build faster, but I think that it builds some products faster than others. And so I designed an experiment where we built 100 boards of all of our different products on the 2 different machines. And lo and behold, like one of the products, if you built it, pretty much everything was twice as fast. But some of the products were 3.5 times as fast on the newer machine. So then if you'd like crunch the numbers and strategically plan what you're going to do, then you could get about 13 weeks of production time back by strategically saying this board goes over here, this board goes over here, and it costs you nothing. Like I made a little card about this big, which had like, starting on the different boards, different directions, like start with this board and never build these over here, et cetera. Anyway, so it was just a really fun thing to both like kind of have that thought in my brain, do the experiment, and then be like, yeah, look at that, because like the SMT time is valued very high. Like making a difference like that, 13 weeks of production was huge, and it was really satisfying to see that.
Is there particularly a huge challenge that maybe you have faced or we have faced in the manufacturing process here?
So we have a little glass diode it's been a problem for probably a decade. And maybe about 2.5 years ago, our VP of manufacturing, Don Christensen, was like, Janine, this is your first priority. Like, we need to figure out what the heck is going on here. And so it was a really tough problem to solve. And it took me about 18 months before we solved it. And then it took about another year to prove that we solved it by working through everything. But it was also really fun. Like, you start out just, like I would make, take pictures. We had a microscope. I bought a fingerprinting kit. Some of your team helped us make really slow-mo videos of things being picked and placed. And so we could see these like diodes jumping in their track. And so it was kind of like a mystery. And I traveled out to Boston to one of our suppliers, and then someone who also would, switch the product from a wafer into the reels. And so we talked to all of the people involved. We showed them the videos. We went to the people that make the machines. And I would be like, okay, here's like my evidence. Like I didn't have any idea what it meant, but it was like, this is what I have observed. And I had this PowerPoint, and it was crazy because people would be like, oh my gosh, like I've never seen that before, or no one's ever said that before. And so over time, we started to get closer and closer. And eventually we found that there were like these tiny microscopic blobs on the diodes. And they did it was like some sort of laser test spectrometer. That's it. They did a laser spectrometer on it and basically evaporated it. And then we're able to see like what elements came off of it. And that fingerprint of elements perfectly aligned with the adhesive that they use when they have like the really thin wafer, they had put it on adhesive tape and then they dice it. So then we knew, okay, like our problem is this adhesive and it's causing it to like jump and stick and do all sorts of things that cause quality issues. And then we had to get into like, well, how is this happening? And at one point in time, our supplier was really hesitant to share what they were doing with us. And so they just said, hey, like that's behind closed doors. And I thought about that for about 2 or 3 days. And I was like, well, I know what kind of tape they're using. I can call their supplier. And I did. So I was like, hey, this is what's happening. And this guy was actually super helpful. And that turned out to be like the key to discovering that it was a UV curing issue that they had. And we were able in the end to solve it, and they got like better control over their equipment. But it was a huge journey, and it was really satisfying to get to the end, and also a little bit anticlimactic because I'm like, yay! I'm like, I think that's I think we've solved it, but then we have to wait and see that everything is continuing to produce. But at this point in time, we're very confident we've got that out of the way, and of course, there's another problem to solve, but we're on it.
It was a huge problem for Wavetronix,
yes,
but it wasn't a Wavetronix problem.
Right.
Caused by
right.
Wavetronix.
And there was a lot of there's a lot of hot potato where people were saying it's the supplier, and then the supplier was saying, no, it's the people who are supplying the pick and place machine. And then they're like, no, it's static at Wavetronix. And so being able to work our way through that and identify the actual issue and solve it was, just took a lot of tenacity. And even within that, like we have such a good process for identifying things that we always make sure that our product going out is amazing and our customers see that.
And so for all that money you spend, I mean, this saves a ton of time and a ton of money, right?
Right. I have one of my friends here would always be like, hey, you're saving us money, right? And I'm like, no, I spend money so that we can make money, make good things happen, and like making good choices with what products, we manufacture with helps us to make a better product.
You touched on this a little bit, but quality assurance, how do you ensure quality at every step of the production process? I know that's a huge thing that we talk about. We really test our products here. And I just wanted to know like how you guys approach it.
Yeah, absolutely. So from the beginning, we have like solder paste that goes on the board, and we have a solder paste inspection that it takes a bunch of different pictures of the solder to make sure that it's the right volume, height, width, everything, which is an impossible task for a human. So that's the first thing, is just like assuring that the board starts the right way. We also have inspection that's called automated optical inspection at the end to make sure that all of the parts have gone down correctly. They can even check polarity and for just like any slippage that might occur in the process of the pick, place, and solder. Beyond that, we do a functionality test. We do environmental testing where we take the boards high and low in temperature and just make sure that they can handle all of the things they might encounter out up on a pole or the hottest part of the world or the coldest part of the world, that the products can be strong and resilient through all of that change. And we also do a final test once we've got it through everything. We actually have several things called anechoic chambers that help to check the radar signal and make sure that it's clean and that it's what we're expecting.
And it all happens right here.
Yep.
We can actually see it out this window. Our viewers can't.
Right.
But everything is manufactured right here.
Right. Yeah. Wavetronix, one of its big stated goals is to keep everything built here and to provide local jobs and great quality. And so everything's happening right here on the floor, and it's local and it's great quality.
Yeah. So built in America, sold in America, the whole BABA thing, right? How important is that to you?
Well, I think it's really important. Like for me, I wouldn't have an amazing place to live and the job that I do if that wasn't a thing. That was, it actually is really hard to find manufacturing in the United States that is thriving. And Wavetronix is definitely a really good example of that, where we have great system set up, we have really wonderful people and an amazing product. And so that combination, there's a lot of synergy here that helps us to succeed and to make great things happen.
And innovation. Like I know I call it the parts vending machine, but there's probably a better name for it, but you brought that on board, right?
Right. So we just recently put in, it's called a VLM, and that stands for vertical lift module. And it allows us to stay in our same kind of, we're, in a little bit of a tight space for how much we're doing here, but it allows us to put shelves 30 feet in the air. And there's like a little laser beam every inch. So as the shelves go back, it can measure exactly how tall the product is. And then it can find a shelf space that meets that. And also kind of like for anyone who's done defragmentation, it'll do that too, where you can run a little program and it'll tighten things up so that you've got a lot of space to fit the next thing in. But that has allowed us to store more things in the same amount of space and also keep it all just really close here. Because, we just have our one building right now that we're making everything happen in.
You made it all make sense to me right there. Defragging manufacturing, right?
Right.
That's super cool.
As for, I already forgot the name, vertical line machine?
Vertical lift module.
Lift module, wow.
Yeah, it's like a magic elevator is what I call it.
What other advancements in manufacturing technology have you seen and excite you the most?
So I get excited about a lot of things. Right now we're putting together a line for our new product Fathom. And so we bought some robots that we're programming out there and are figuring out, basically how much can we get each robot to do, and how do we line things up in a way that makes sense, and if the product grows, what sorts of things do we need in line after that. So far it's, we have just one robot to load and unload and kind of trim the sprues off of the product, but it's we do have, a larger plan for, as we receive orders, that we can respond to them and make changes according to our need. But there's always the next thing on the horizon that will help us to go a little bit faster with a little bit higher quality, and just, continue to grow and improve.
What do all of these improvements mean for not just Wavetronix, but for Wavetronix's customers?
So I think that the probably some of the big improvements are that we are continually dialing in our process so that we can provide a better product. That it's just, tightening up all of your little processes means that it's more and more reliable. We already have an amazing track record of what we're putting out, but we are never satisfied with that. We're like, let's make it better. What can we do to make it better? And so anytime that you improve your process or bring it further under control, you end up with better results, better quality, better output. And the result of always striving to learn and to improve gets passed on to the customer, as well as it makes it a nice place to work also. If you're, excited about what you're doing and if you feel good about it, it makes a difference.
How much do you pay attention to lead times? Is that a part of what you have to worry about?
So lead times are a little bit less my wheelhouse, but especially when we were coming out of COVID, that was a big deal. And that was part of why I was working on the SMT line. But going back to the example that I gave before about, like if we can double our production rate, that helped lead times out a lot. And so I think we brought lead times under control quite a bit. And it's always a little bit of a balance. Like you can always make things go faster if you bring on more machines or more people. So we're always just trying to balance a little bit on what our demand is and meeting the demand and planning for future demand. But right now, the lead times I understand are pretty good, maybe around 6 to 8 weeks. And so we're good with that too.
Yeah.
Just curious, as for people starting their, careers in manufacturing or manufacturing engineering, what advice would you give someone who's just starting out?
I would just say that the biggest things that you need are like curiosity, tenacity, and a willingness to learn things you don't know yet, because there's no way for any of us that we could really be prepared in school for all of the challenges and questions that we face. But that's also what's really exciting. Like going back to the diet, I was dealing with a question that nobody knew the answer to. Sometimes in training, like when they're getting you on board and they're like, if you have a question you don't know the answer to, like go ask your go ask your manager, or go ask someone else. And then it's like, in our field, a lot of times you have a question that's a problem and nobody knows the answer, literally. And so then it becomes a really fun quest. And so I would, I guess, encourage people who were interested in this field to, examine their curiosity and just make sure, like, you have to kind of not give up on things, to just dig in. And when one thing shuts down, you just sit there and you have to pick and kick until the next thing opens up. And just, there were some days there when I thought I had discovered the problem, and I found out it wasn't, and I would just I'd just be like, I'm going to take just a little break and just spin in my chair for a few minutes, go get a drink. And, sometimes I'd go and work on something else for the rest of the day, but always just like being willing to come back and be like, all right, like, I'm going to win. What's next,
That's an amazing attitude. Like, I think I would get so frustrated, especially how long it took to discover what the issue was and then get it resolved, have people believe you.
Right.
Were there ever those times where you're just like, okay, this is crazy, it'll never get solved, it's not worth it?
I definitely had days that I felt that way, but I didn't voice it. That I'd just be like, I'm so done with this today, But there's always something else I could, work on for a little bit and just work on regulating that, and just like, and some of it is like, I always joke I have like a back brain that just will churn like at night and when I'm asleep, and then I'll eventually hit on what I think the next thing is, kind of like when I was saying that supplier wouldn't give us any information, they wouldn't let us see what they were doing either. And that took me a few days to be like, oh my gosh, like, how do we move forward? Until I was like, yeah, I'll just, like, I know the name of the supplier for the tape, I'll call them. And they were super helpful. And it was like, it always is a matter of patience and perseverance. And yeah, definitely have my days of discouragement, but life moves on.
Yeah, it paid off. Back brain. I need one of those.
I do too.
Man,
I like my back brain. It does amazing things.
Is that why you're such a good pickleball player?
I just think that's more like response than back brain, because you don't have time to think about pickleball. It's just like, right?
Yeah,
but
true. So is there anything else you want to discuss, focus on that we haven't asked you about?
Well, I think that mostly it's just, it's interesting to see what sorts of things we're doing out here. And if anyone is wanting to ever get a tour of Wavetronix, we love to give tours. And one of my favorite things is showing people around the floor and letting them see firsthand, like, hey, this is what our SMT line looks like, and all the different stages that things go through. And I think my favorite tour I gave to was a 5-year-old that someone had their grandchild, and like at one point in time he couldn't see in the machines, and so I like lift him up and have him on my hip, and I'm explaining like the selective solder, which is kind of like a fondue fountain of molten metal, that it's really fun to look at, But after I got done, his grandfather was like, he's like, I didn't know you gave tours where you like pick people up and explain. I was like, yeah, that's my first one. But I do love, getting to show people firsthand. And so I would just say, like, if people are interested, come have a look. We love to give tours and love to show off what we're doing.
Yeah. Well, we appreciate you coming on the podcast and having a chat with us.
My pleasure. It's fun to be here.
Yeah, it's fun to get to know you better.
Thanks.
And thank you for joining us for the Pulse podcast from Wavetronix. We'll see you next time.